Shall we start the session now?
Yes, ma'am.
Okay. We now move on the technical session one, which will focus on innovative research contribution in the area of future technologies and applied systems. This session brings together research work that reflect the current trends, challenges, and the future direction in technologies and applied systems. It is my privilege to introduce the esteemed chairpersons from this session. Dr. S. Annie Kathleen, Assistant Professor, Department of Computer Application, Agrigan Management Jain College, Chennai. Sri G. Balaji Sir, Assistant Professor and Head, Department of Computer Science, Vivekananda College, Madurai. Sri C. Ranjit Kumar Sir, Assistant Professor, Department of Computer Science, Vivekananda College. We warmly welcome our respected chairperson and thank them for their valuable guidance. First paper one presentation is I now invite Mr. R. Manoj Kumar and Mr. R. Charan to present the paper titled Real-Time Monitoring Helmet for Miners Using IoT. Welcome, sir. Charan, sir.
Yes, ma'am. Good morning to all.
Good morning, sir.
Let me present my paper. May I, ma'am? May I?
Yes, sir. Your voice is audible. You can continue.
Okay, ma'am. Can I present my screen, ma'am?
Yeah, yes, sir.
Ma'am, can you see my screen?
Yes, sir.
Okay. Miners are often exposed to toxic gases, poor air quality, high humidity, and low visibility, which can lead to serious accidents. These accidents can happen because of some dangers that are not detected earlier. To address this problem, this work proposes a prototype of an IoT-based miner safety helmet that continuously monitors the miner's surroundings. The main objective is to improve miner safety by detecting harmful gases in real time, monitoring humidity, alerting the miner immediately when threshold values cross safe limits. Main components used for the prototype are node MCU, a gas sensor, which is nothing but MQ9, and a humidity sensor, a buzzer, LED display, and some of the LDR components. Here, the gas sensor is used to detect whether some harmful gases such as carbon monoxide, methane, and some LPG gases, when they are detected outside in a mine or a tunnel where they are digging, uh, our helmet, that is the prototype, will help them to detect the harmful gases and alert the miner immediately. If the miners are not able to, if they cannot detect the gas or didn't receive an alert message, the supervisors outside the tunnel or a mine can see them from a cloud application such as B-Link or any other mobile app. Humidity sensors are used to measure the moisture level in the environment. The node MCU acts as the brain of the system in which all the sensors, information or data are sent to them, and this node MCU acts as a Wi-Fi module which sends the data to the mobile application such as B-Link. The LCD display, we have used this to show the real-time values clearly on the helmet. Obviously, the buzzer is used to alert the miner during danger. Here, all the components are mounted on a safety helmet, making it wearable and practical. When the helmet is powered on, electrical power is supplied to the node MCU, and all the connected sensors are to be started working. The microcontroller initializes all sensor pins. Threshold values for gas concentration and humidity are already stored in the program. The Wi-Fi module inside the node MCU establishes a connection with the predefined network. After initialization, the MQ9 gas sensor starts to measure the concentration of harmful gases such as carbon monoxide and etc. If no harmful gas is detected, there will be no alerts. If the sensor gets to detect some, it alerts the miner through the buzzer and alert message is displayed on the helmet. And so, likewise, the LDR, dependent resistor, checks whether sufficient light is present in the mining area. All these sensors send their reading to the node MCU at regular intervals, so the supervisors or any miner can seek through the danger and evacuate from the tunnel or mine immediately. Uh, Thank you everyone for listening, and thank you for this opportunity. Thank you.
Thank you for the informative presentation. I now request our respected chairperson to kindly their questions, comments, or feedback.
Sir, first of all, very nice presentation, and your topic is very good. It's really very useful. This helmet, your topic is even real time applicable, sir?
Yes, ma'am, it is real-timely applicable, but this is just a prototype, ma'am. A low
Okay,
budget.
okay, okay, sir, okay, sir.
Good morning, Charan.
Good morning, sir.
Good morning. Your presentation is nice.
Thank you, sir. Thank you.
In gassing sensor, what are the working principles of gas sensor?
Uh, in every gas sensor, the outputs can be I mean, the input will be sent into analog signal. The value is converted into digital signal by the microcontroller. The obtained value is compared with the predefined safe threshold level. If the gas
Oh,
concentration is below the threshold, the place is safe. If the concentration exceeds the threshold, place is not safe.
okay. What are the types of gas sensor?
There are obviously series in some of the sensors like MQ. MQ is some of the series, sir.
Hmm.
We have used MQ9 sensor here, which can detect only carbon monoxide, methane, and LPG gas. If any other
Okay.
gases are to be detected, we need another type of series sensor which can detect other gases. But
Great.
this is just a prototype. Just a prototype.
Thank you, Pa. Thank you.
Uh,
Thanks.
Very nice presentation, Charan.
Thank you, sir.
The question is, what type of you are using gas sensors, right? So that is only to detect carbon monoxide alone. Uh, do we, because today vehicles they use CNG gases also.
Uh,
Do you have any what you call the prototype which can detect those kind of leakages also?
yes, sir. The helmet which is made now is prototype
Mhm.
with a small budget.
Mhm.
The gas sensor is actually 190 rupees.
Oh,
These
oh,
types
oh.
of sensors can detect any gases. For
Mhm.
example, the CNG lighter, with the small
Mhm.
lighter, cigarette lighter, we can make the sensor buzzer.
Okay.
But with the high level working sensors, it can detect the actual gas, such as carbon monoxide, LPG, and so on, sir.
So can this prototype be applicable for you are using only in helmets, right? So is it,
This
can
this
it be
prototype
converted into
this
other
prototype is used to explain,
vehicles?
sir,
Okay, okay, okay.
but not in fields. We have not yet tested in the fields such as mining fields
Hmm.
and tunnels, but for explaining, we have made this prototype, sir.
Okay. Nice presentation. Sure. Thank you.
Thank you so much, sir. Next, I invite Sanjita Khatun to present the paper title is of secondary school teacher towards the flipped learning as the strategy for promoting 21st century skills. Welcome, sir.
Hello, good afternoon, ma'am.
Yes, ma'am. Good afternoon.
Yes, good afternoon, ma'am.
Ma'am, my screen is visible.
Not visible, ma'am. Your voice only audible.
Okay, ma'am. Ma'am, now my screen is visible.
No.
Ma'am, now?
No, ma'am, not visible, ma'am.
Okay, ma'am. Ma'am, I think network issue. Ma'am, then? Ma'am, now it's visible.
Yeah, it's visible, ma'am.
Okay,
What
okay.
about the
Thank
first
you so
class?
much, ma'am. Okay, ma'am. Okay, ma'am.
Okay.
Uh,
Good afternoon, everyone. Myself, Sanchida Khatun, a research scholar of Maulana Azad National Urdu University, Hyderabad. Today, my paper title is Perception of Secondary School Teachers Towards Flipped Learning as a Strategy for Promoting 21st Century Skills. Uh, if we talk about why flipped learning matters in today's educational system, the answer is so simple that the traditional method failed to address emerging educational needs of the child and also leaving students unprepared for their real life challenges. But in other hand, the flipped learning is a very innovative pedagogy where students learn at their own pace and own time. They are learning at home and in class they discuss their doubts. Uh, so the flipped learning foster independence and deeper engagement of the learner, and it also aligns with 21st century educational needs. Objectives and research questions. The first objective is to examine secondary school teachers' perception towards flipped learning, to analyze the role of flipped learning in promoting 21st century skills. The third one is to identify major benefits and challenges in implementation of flipped learning. A research question: what are teachers' perception of flipped learning? Second one is how effective is it for developing the 21st century skill? And the last one is what barriers and opportunities exist from educators' perspectives. Research methodology. In the paper, the researcher used qualitative descriptive research design based on comprehensive secondary data. Teachers' perception towards flipped learning. Uh, Many secondary teachers view that flipped learning as a valuable tool to enhance student-centered learning. And they show a positive attitude towards flipped learning, that it improve student engagement, active learning, and higher order thinking skill. And they also highlight some implementational challenges such as quality online material, student self-direction training, and equitable access of technological infrastructure. Then evidence from recent studies, there are so many evidence that show the effectiveness of flipped learning in compared to traditional method. Uh, they they said that flipped learning is significantly impact on students' academic achievement, their creativity, their thinking skills, and so on. 21st century skills fostered by flipped learning. Uh, by flipped learning, students learn their own space and control their self-learning at their own pace. It promotes critical thinking, problem solving, and collaboration, communication. That is children able to learn digital literacy, know values of citizenship, and also it inculcate creativity and innovation as well as social skills of the child. Then visualizing the paradigm shift. Uh, the first is traditional, then it transition, and then after flipped. It means the traditional learning uh, is not more effective. Instead of flipped learning, the flipped learning transformed the role of educators from siege on the stage and to guide on the side. Here are some secondary educators' insight towards flipped learning, and they show their positive perception as positive attitudes towards flipped learning. Then overcoming implementational challenges. Some key support strategies. The first one is professional development. then student support system, technological access, and continuous improvement of both teacher and student. Conclusion, embracing flipped learning for 21st century success. Uh, the flipped learning is effective, a powerful strategy to cultivate essential 21st century skills into the learner. And research consistently support that its positive effect on academic achievement. And it also transform education to meet future challenges. So let's empower as well as educators and learners to flip the classroom and unlock the full potential of 21st century education. Thank you so much, ma'am.
Hello.
Yes, sir.
Your presentation is nice. Yes, my question is, how is flipped learning different from traditional teaching?
Sir, basically in traditional teaching, the student learn at in class basic Bloom's taxonomy. They learn knowledge, understanding, remembering. But in flipped
Hmm.
learning, they all know the basic skills, just knowledge remembering in at their home, and basically discuss their doubts, which are based on analytics, creative. This is
Hmm.
in the class. So
Okay,
when
so
we
my,
face any challenges, then we talk to pair and teacher as well.
it's okay. So my another question: how does flipped learning help slow learners?
Please repeat the question.
How does flipped learning help slow learners? Slow learners. How does flipped learning help slow learners?
Sir, deep learning in help helps a slow learner as we know, slow learners are very their learning process is very slow. They learn lower.
Hmm. How does it help?
So I think it helps in their they learn their own pace, own time, and as much as repeat their content instead of
Repeat the.
higher order.
It's correct. Repeat the content.
Yes,
It can watch the videos multiple times and learn at the own pace.
yes, yes, yes.
So. Okay, ma'am. Thank you.
Thank you.
Hello, Sajadin madam. Hello.
Yes, sir.
Hello.
Yes, sir. Audible, sir. Catherine, ma'am.
Ma'am.
Any questions, ma'am?
Yeah, ma'am. Sanjita, ma'am.
Okay.
Yes, ma'am.
Yeah, your presentation is very good.
Thank you, ma'am.
Okay, ma'am. Sir is asking what is the difference between traditional and flipped classroom. Then Sir is asking the two more questions. So okay, you are telling all the question for the correct answers. Okay. Then my question is, are you using in the flipped classroom in your school, ma'am?
Ma'am, it is my research topic,
Okay.
so
Are you
I am
using in the
used it.
colleges also? You are
Yes,
using the flipped classroom in your colleges?
ma'am. I am
In
a
your
school teacher and I used it.
okay, okay. Then students feel how, ma'am? How is your feel?
Ma'am, they are very happy to this teaching method.
Okay, ma'am. Okay. Okay. Thank you, ma'am.
Thank you, ma'am.
Ma'am, okay, ma'am. Next is
Ranjit sir, any questions, sir?
No, ma'am. Kindly go to the next presenter.
Okay, sir. Next, I invite to Gopikanan and or Mahendra to present the paper title as Assessing and Algorithm Bias in Healthcare AI Using Real World Data. Welcome, sir.
Welcome, ma'am. Good morning to respected chairpersons, reviewers, and fellow researchers. I am R. Nagendran. I am today presenting the overview work on assessing and mitigation algorithmic bias in healthcare using real-world data. Ma'am, I can take screen, ma'am. Share screen, ma'am.
Yeah, yes, sir.
Even advanced AI system can unintentionally forward certain group of the patients of disadvantaging. Other over the studies reveals the extending method of the measure reduce the bias using real world healthcare data. Then the next one, the healthcare the system learning the historical hospital data. If data did not equal represent the patient's group, they may produce unfair the predictions. The next, we conducted two phases the literature's review. The first one, they studied the general fairness, the bias mitigation techniques and machine learning. This examined the these techniques employed the specific in the healthcare systems. The next architecture images. The architecture is the three processing of the components method. The first one, pre-processing method. The next one, in-processing method, the post-processing method. The architecture to show the web bias can be introduced and we can apply the mitigation techniques before training, during the training, after model the predictions. The components step by step. The first component, the bias mitigation method, the pre-processing techniques. The examples, the data sets, the mostly male patients, the balanced it by the include more the female patients data set. The next, in processing techniques, the model of the panelists treat the different group of the fairness. The next, post-processing techniques. In the instance adjusting approval that distort the outcome of the fair across groups. The next, the conclusions paper. The ensuring fairness, the healthcare is just the technical challenges, but the ethical, the responsibilities, the futures research, the focus on the developing the robot, the genericable and fairness solutions using discover real world data. This thank you for presentations and chairpersons.
Thank you, sir. Informative presentation. I now request our respected chairperson to kindly share their questions, comments, or feedback.
Sir, our presentation is nice.
Sir,
The audible.
yes, sir.
Uh, Give some examples of image post processing technique.
Post processing techniques.
Some examples for image post processing techniques.
Image.
Yeah. Any examples?
Any examples, post processing, the grouping, the billing system, electronical grouping data, sir.
I am asking for the image post processing.
Image processing. Contextual scheduling, sir. Histogram equalizations and brightness and context adjustment and gamma corrections, sir.
Okay. Yes, thank you.
Oh, thank you, sir.
Sir, your presentation was very nice. What are the machine learning models would you suggest for the healthcare management? Give some examples.
And it's not work to real world examples. The future update of the real world bias using mitigation. Future developing useful of the methods.
Okay, sir.
Thank you.
Thank you, sir.
Thank you.
Good afternoon to all.
Catherine, ma'am.
Yes, ma'am. Hi, sir. Good afternoon. Your presentation is very nice.
Okay, ma'am.
Do you compare with any other methodology are you using for healthcare?
Healthcare is very complicated method. The machine learning using for just all time no using only the bill counting the scan its spray and point of the method of the using only real world data using a method bias mitigation method. Ma'am.
Okay. Do you compare with any other methods? Only you compare only bio methods, biops only.
The machine learning and other common healthcare methods and widely used in the healthcare management. Ma'am.
Okay. Thank you.
Discussing mapping adaptability and activity example, ma'am.
Okay, sir. Thank you.
Thank you.
Thank you, sir. Next, I invite Dr. B. Uma Devi, ma'am, to present the paper titled Intelligent IoT System for Sustainable Future Technologies. Welcome, ma'am.
So good afternoon to all.
Good afternoon, ma'am.
So I'm audible, ma'am.
Yeah,
Ma'am.
yes, ma'am. Audible, ma'am.
Okay. So I'm Professor Uma Devi from Nehru Memorial College. So Intelligent IoT System for Sustainable Futures and Technology. Shall I start, ma'am?
Yeah, yes, ma'am.
So already we know that intelligent systems like edge computing, machine learning, and artificial intelligence together tied up with some other IoT systems that create some vital effective in the development of sustainable future technologies. For example, some energy efficiency and cut down the resource waste like that. And even though their distribution application focused on sustainable are presented, I think in this research focus, like facilitate a data-driven and ecological conscious decision making process. And by the result, the intelligent IoT system maximize the resource consumption and greatly improve in the real-time processing capabilities and meet the sustainable development objectives. Actually, the problem is in the conventional IoT methods. So the sustainable consideration like energy efficiency and other some other connection with the data drivens are a little bit low. And while becoming for the large scale sustainable application, it cannot be benefit from the central processing architecture since they increase latency and bandwidth consumption, like power consumption and etc. And this intelligent IoT system can process data effectively, make adaptive decisions, and fewer resources are required. These are the problem statements. And our objectives are to examine how the intelligent IoT systems to help sustainable future technologies, and we are investigate the current development in IoT architecture facilities and including resource optimization and energy efficiency for the advance of the sustainability, and to determine unresolvedness and potential or the future studies. So here enabling technologies for intelligent IoT. Usually already in IoT systems are there, the multiple enabling technologies with, we are tied up with artificial intelligence, machine learning, and some other technique we are using with the predictive analysis and anomaly detection, and also the adaptive control mechanisms. So while it is mingled with the edge computing enhance the system efficiency by the processing data sources, and they are reducing the latencies and network congestion also, and that's why it's produced some other overall energy consumption. So intelligent IoT for the sustainable applications. So same what we told previously, that intelligent IoT system mingled with AI and ML with edge computing, and these technologies support informed decision making process and enhance system adaptability and promote sustainable resource utilization in the environmental consciousness with IoT applications. Energy efficiency and resource optimization in intelligent IoT. Actually, the adaptive sensing strategies with energy aware routing protocols and optimized workload distribution, like some other cloud computing technologies, to reduce the power consumption across the network components. And machine learning models also enable the predictive maintenance and optimal task scheduling and minimize the redundancy operations in the databases and extending device lifetime. So this edge computing also, plays the vital role in the enhancing the sustainability of IoT architecture by enabling localized data processing and real-time decision-making process for the current future time to the society. And this intelligent IoT system reduce reliance on central cloud resources, thereby lowering communication overhead and improving the system reliability. And these centralized architectures support scalability while maintaining energy efficiency and making it particularly suitable for such as smart healthcare industries, automations, and other some environmental monitoring system like climate controls and all. So green IoT for the sustainable intelligence system. So the green IoT refers to the design and deployment of IoT system with emphasis on reducing energy consumption and lowering carbon emissions, and some promoting environmental responsibility practices. So it integrate energy efficient hardware support like microcontrollers and low power communication protocols like CNN models, and intelligent data analytics and renewable energy resources minimize the environmental impact of the IoT structure. Sorry, system is slow a little bit. So application-wise sustainability impact. So here in smart cities, IoT functionalities and what are the sustainable impacts. Smart cities, traffic and pollution monitoring, and it reduces emission. And smart agriculture, soil cropping sensing and water conservations in sustainable impact. And smart grid computing, energy demand forecasting and energy efficiency. In waste management, smart bins and analytics reduce the waste, and in environmental monitoring, air, water quality sensing and ecosystem. These are practically done in what we are living in the Trichy Corporation with the smart city project under traffic and pollution monitoring, and also the smart bins and analytics with reduce the waste. Real time we are showing in the Trichy municipality. And comparison with traditional IoT systems, data processing is traditional, this is centralized. But in intelligent IoT, it is with edge with cloud computing. So scalability, shareability, flexibility are very high in the intelligent IoT system compared with the traditional method. And decision making, this is rule based, but that is AI driven. So take real time decision is possible. And energy efficiency is very low, but it's high. And scalability limited, but highly scalable. Sustainability support minimal, but very strong when you are using intelligent IoT systems. So conclusions, by integrating AI, edge computing and data analytics intelligent IoT architectures, enhance energy efficiency, optimize resource utilization and support environmentally responsible applications, while promising challenges related to security, scalability, interoperability must be addressed. And for the future resource also emphasizing energy awareness intelligence and secure distributed system learning and standard IoT framework ensure the long-term sustainability. And these are all the references. Thank you, ma'am.
Sir, your good name?
I'm Dr. Uma Devi, Assistant Professor from Nehru Memorial College, Trichy.
Okay. Your presentation is nice. Your content also is effectively.
Yes, sir. We are
Yes,
doing
my.
some of my PhD students also doing in IoT related work together
Uh,
with Central Research Banana Research Center, sir, using
uh,
IoT some boosting algorithms.
okay, ma'am. Okay, ma'am. It's my question is,
Yes.
how do intelligent IoT systems reduce energy consumption?
Because no sir, we are doing, for example, in Trichy city,
Hmm.
6 o'clock immediately automatically because under smart city project,
Hmm.
automatically 6 o'clock by the time of the computational system, automatically the lights are in the on, and
Hmm.
same like that depends on the climate condition. From the intelligent devices, they are getting messages from
Oh.
the department. So for
Hmm.
5:30 or depends on the sunrise and the climate condition, automatically the lights are shutting down, sir. So like that,
Okay,
some
ma'am.
other projects also doing the real time we are trying the energy consumption saving for the sustainable
Okay.
energy using intelligent IoT systems.
Okay, ma'am. Okay. It's my another question.
Yes, sir.
Why is data analytics important in intelligent IoT?
Sir, I can't understand.
Why is
Yes,
data
sir.
analytics important in intelligent IoT?
Because no, sir. For example, same example I am doing that. I'm
Uh,
telling that because 6 o'clock they are like on the lights, so they are
hmm.
comparing every day with the energy consumption with the data analytics, and in the summer and winter and some other seasons they are I mean taking the same data and they are doing data analytics to how reduce the energy in future also, sir.
What are the challenges in a
One example, same like that, not only in electricity problem and smart cities and some other environment, that is data analytics must to compare and take the real-time decision making process. It is must, sir.
Okay, ma'am. Okay, ma'am. Thank you.
Thank you,
Thank
sir.
you for nice answer.
Thank you.
Thank you.
Ma'am, your presentation is very good.
Thank you, ma'am.
So, no more questions, ma'am. Thank you.
Thanks a lot.
Thank
How
you.
are you?
Thank you. Thank you, ma'am. Thank you.
Ranjit sir,
Madam,
any questions, sir?
questions, presentation, questions கேட்கறதுல they have already asked this. Madam Sarah has already asked.
Thank you.
Maybe the next presentation I'll look it up. Thank you.
Thank you so much, sir.
Okay. Shall we conclude the session, sir?
Yes, ma'am.
Yeah, ma'am.
Yes, madam. Yes,
Okay.
madam.
Thank you to all the presenter for your sharing valuable research contribution. We also express our sincere gratitude to the respected chairperson for the effective moderation and insightful comments. With this, we conclude technical session. Thank you all. Thank you so much, sir. Balaji sir, Ranjit sir, Catherine ma'am, and all presenters. Thank you so much, sir.
Thank you, ma'am.
Thank you. Thank
Thank
you,
you,
ma'am.
madam.
Thank,
Thank you.
thank you,
Thank you.
ma'am.
Thank you.
Thank you. Thank you.
Yeah.
Thanks.